All right, hey everybody. So this is going to be like say part 3, but you're not going to see anything new in this part than you had seen in the previous parts. We're still going to find missing side lengths. Once we find all the side lengths, we're then going to add them together to find the missing perimeter or the perimeter that they're asking for here. All right. So just like the previous problems, first steps first. Let us identify a reference angle and set up our triangle. All right. So we're not going to. Here we go. So we're going to use the angle that we were given again. That's the safest bet by far to use this as a reference angle. Okay, and once we have the reference angle, then we can label the top as our opposite side because it's not touching our reference angle. We know that we have the hypotenuse. And then, of course, we have the adjacent. Okay, so we must find the adjacent, we must find the opposite given the hypotenuse. Let's find adjacent first. At this point, hopefully you realize it doesn't really matter which one we start with because the technique is going to be the same. We have our reference angle, our reference triangle, excuse me, that we're going to compare to our actual triangle. Because those are going to be inherently similar because of the right angle and the reference angle. We need to find adjacent. We were given a hypotenuse, and so we'll use adjacent over hypotenuse for that 22-degree angle. Okay, for both triangles, both the actual triangle that we're trying to solve, okay, and the reference triangle that we'll find in this case in our calculator. A over h is how we see it. Of course, our calculator is going to see it as cosine. Because keep in mind, SOHCAHTOA, that trick that we were talking about to help us remember the order, okay, is still in play. So for the cosine of 22, adjacent is going to be the thing we're trying to find, and so we'll just use A. Hypotenuse is what we're given to help find it, okay, that's going to be 34. Okay. Now, of course, we need to convert cosine of 22 into a decimal. That's how we are able to actually use it effectively. And so, there it is. As soon as I can find my calculator. Okay, I have 22, cosine of 22 is 0.9272. We'll put it over 1, of course, and so we can cross multiply. Okay. So that's going to be equal to A over 34. Okay, so we cross multiply, solve for A, 0.9272. Then we have an approximate A value of 31.525. Okay, so doing a quick check, that is going to be smaller than my hypotenuse. Not a lot smaller, but it does fit within the hinge theorem. Okay, let's now solve for opposite side. Okay, and just to shake things up, I think the last couple times I've used trig. Let's use the Pythagorean theorem here because it's just as good as a method. I personally, sorry about that. My board's being very, very slow right now. So I personally prefer just setting up another trigonometric problem using sine, cosine, or tangent. But this method is just as good. Riskier because we have to use a value that we personally calculated, and we could have been wrong with the adjacent side. But sometimes we just have to trust ourselves. So let's just use that. The adjacent side, A, I'll use 4A. So that we got 31.525. Okay, we'll square that. Okay, we'll add that to the opposite side, which we're trying to find. And so that's going to be like OP squared. That's going to essentially be like our X value. And then we were given the hypotenuse to be 34. That'd be 34 squared. All right, so 31.525 times itself. Pretty close to 1,000. We have 993.826. Okay, plus our unknown OP value, which is still squared because we haven't resolved the square yet. And 34 times itself is going to be 1156. Okay, so now we just go into our solving routine. So we can subtract 993.826 from both sides. And that will leave us with 162.174. Okay. And that's an action. It's supposed to be an equal sign there. Again, my board is just being unbelievably slow right now. Okay, there we go. Now, of course, to resolve the square, we'll square root both sides. Okay, so the OP value is going to be approximately 12.735. Okay, so 12.735. Okay, and again, that fits because it's across from the smallest angle. It should be the smallest side. The adjacent side would be the next largest angle, therefore next largest side. Of course, hypotenuse is the largest. One last thing to do, if my board can handle it, we need to find the perimeter. Let's stick it in right here. Okay, so let's add these three pieces together. So 34 from what I was given, 31.525. And then 12.735. Okay, and so we have a total perimeter of 78, or about approximately 78.260. And again, I'm saying approximate only because I know I'm doing a lot of rounding, therefore I know that value is going to be an approximate one. All right. So let's set up our routine again for number 2. Reference angle first. Okay, labeling second. Opposite. Here's our hypotenuse. Okay, and then we have our adjacent. So we had to find our adjacent side and our we had to find our we just have x. Oh, so here's something interesting. So we don't have any of our side lengths. We don't have the opposite, we don't have the adjacent, we also don't have the hypotenuse. So this is unsolvable. Okay, so we don't have any sides given. We have no way to actually calculate a side. Therefore, this problem will be unsolvable, which is something I didn't expect, but like it's there. And so like that's how we have to deal with that because we can't always solve these problems. All right, so that's going to be part 3. I believe we have one more pair in this set. Looks like these will both be solvable because we do have side lengths. And that's where you guys will see me in a couple minutes.